So hello everyone, my name is Prachi and I am your chemistry SME. So let's start with the solution of full test 5 for the chemistry portion section A. For question number 51, it is asked that the accurate sequence of stability for carbon ions. So we have to find out the accurate sequence of the stability of carbon ions. So for carbon ions, the stability of carbon ions is determined by the degree of delocalization of negative charge. Okay, which means that the stability of carbon ion, here we can say that the stability of carbon ion is directly proportional to electron withdrawing group. Okay, if any electron withdrawing group is present, then the stability of carbon ion will increase, and if any electron donating group is present, the stability of carbon ion will decrease. Okay, so electron withdrawing group is directly proportional to stability of carbon ion, and it is inversely proportional to stability of electron donating group. Okay, so let's see, these are the four options given here. So here this part is common in all of them, right? This part is common in all the options. So now let us say what is varied here. Here NO2 group is there, here Cl, here OCH3 and here CH3. Okay, so we know that NO2 is an electron withdrawing group. It is an electron withdrawing group. Chlorine is also an electron withdrawing group. OCH3 is also an electron withdrawing group, and CH3 is a electron donating group. Okay, so if it is electron donating, then its stability will be the least among all these four. So let's see the stability of fourth one is the least. Okay, so here in option 2 the fourth one has the least stability, and in option 3 also the fourth one has the least stability, which means that option 1 and option 4 are incorrect. Now let's arrange these electron withdrawing group on the order. So the order of electron withdrawing group among these three. What will be the order of the electron withdrawing group? So here we can say that the nitro group has the highest electron withdrawing tendency. Then comes the Cl group, and then at the least comes the OCH3 group. Okay. So now NO2 group, where NO2 group is attached, which means the option 1, it will have the maximum stability. So option 1 stability is the highest in both cases. Then after Cl has the second highest stability of carbon ion. So option 2 comes here. Option 2 comes here, and then OCH3 group has the third highest stability, which means that option 3 is the correct answer for this question, right? So now let's see the second question. In a flask at a certain temperature, there are 2 gram H2 and 8 gram O2. The mole fraction of O2 in the given mixture is. So what is the mole fraction of O2? We have to find out. Okay. So we know that what is the formula for mole fraction. The mole fraction of any compound is the moles of a component divided by total number of moles of component, right? This is the formula for the mole fraction. So let's say we have to find out the mole fraction of O2, right? The mole fraction of O2 we have to find. So what will be the mole fraction of O2? It will be moles of O2 divided by total moles of O2 plus total moles of H2 Okay, here H2 is also there, right? So then we can find out the number of moles of hydrogen. So what is the number of moles of hydrogen? It is weight of hydrogen by its molecular weight, which means that weight of hydrogen is 2 and its molecular weight is also 2. H2 it is there, na? So its molecular weight comes out to be 2, 1 for each hydrogen, which means that number of moles of H2 is 1. Then we have to find out the number of moles of O2. So number of moles of O2 is weight of O2 by its molecular weight. So weight of O2 is given in the question, it is 8 gram. So it is 8 by 32, which means number of moles of O2 is 1 by 4, right? So now we have to find out, now let's find out some space. Yeah, here we can write. So now we can find out the mole fraction. Okay, so what will be the mole fraction of O2? It will be number of moles of oxygen, which comes out to be 1 by 4 by number of moles of oxygen plus number of moles of hydrogen. So here on solving we will get the answer as 1.5, which is 0.2, right? So hence, so therefore the option 2 will be the correct answer, which is 0.2. Okay, so let's see the next question. Question number 53. The structure of IF7 is, what is the structure of IF7? So for IF7, we need to draw the molecule first. So let's provide us with some space. Okay. For IF7, there is I is the central, iodine is the central atom, and then it is covered with 7 fluorine atoms. Okay, like this. Okay, so here this type of structure is formed. Okay, it is a structure of, what is the geometry of this molecule? It is pentagonal bipyramidal. Okay, pentagonal bipyramidal. So option number 2, pentagonal bipyramidal, is the correct answer. For question number 54, which of the following compound does not undergo Friedel-Crafts reaction? Okay, so Friedel-Crafts reaction is not shown by this, the group containing the carboxylic acid, COOH. Okay, why? Because the carboxylic acid will react with the Lewis acid catalyst. Okay, Lewis acid catalyst, which is present in the Friedel-Crafts reaction. What is the Lewis acid catalyst that is present in the Friedel-Crafts reaction? Yeah, it is AlCl3. Okay, so what happens that this COOH group, carboxylic group, reacts with the Lewis acid catalyst of Friedel-Crafts reaction. Therefore, it does not give reaction with Friedel-Crafts reagent. Okay. For the next question, question number 55. Determine the mass percentage of methanol in the solution if molality of methanol in water is, okay, we have to find out the mass percentage of methanol. So let us see. For question number 55, what is the formula for mass percentage? The formula for mass percentage is components mass divided by total mass into 100. Okay, this is the formula for mass percentage. So we know that the moles of methanol is 5. Okay, and the mass of water is 100 gram. It is given the molality of the moles of methanol is given in the question, it is 5, and we are calculating it per 1000 gram of water. Okay, so what will be the mass of methanol? It will be 32 into 5. 32 is the molecular weight, so it comes out to be 160 gram. Then mass of the solution is 1160. Okay, we have to add this mass of water, and mass of methanol is the mass of solution, right? So on solving this, the mass percentage of methanol comes out to be, components mass is 160, total mass is 1160 into 100, which comes out to be 13.8%. Okay, option number 3 is the correct answer. For question number 56, identify the major product of the given reaction. Okay, this is the reaction given here. So for question number 56, this is the reaction. On adding water, what happens that the bromine atom is removed. Okay, and here a positive charge is formed. Upon cyclization, this type of compound is formed. Okay, then what happens that this positive charge gets shifted towards another carbon. It is called hydrogen shift, right? So after that, on adding water, what happens that an OH group is introduced here. So this will be the final product. On seeing the options, we came to a conclusion that option number 3 is the correct answer here, right? For question number 57, determine the de Broglie wavelength of a particle of mass of 6.62 into 10 to the power minus 22 kg moving with 1 meter per second speed. Planck's constant is given in the question. Okay, so determine the de Broglie wavelength of a particle of mass of itna. Mass is given and the speed is given, which is 1 meter per second. Planck's constant is also given. So upon putting this in the de Broglie equation, lambda equals to h by mv. Okay, so h is Planck's constant is given in the question, mass is also given in the question, and the velocity is also given. So upon solving this comes out to be, wavelength comes out to be 0.01 Armstrong. Okay, option number 1, 0.01 Armstrong is the correct answer. For question number 58, 58 says that iodoform reaction is not given by which of the following. Okay, so iodoform reaction is not given by which of the following: CH3CHO, C2H5OH, CH3CO, or we can say that it is C double bond O, right? CH3, C double bond O, CH3. Next is CH3OH. Okay, so it also has a CH3COO bond here. So the compounds, the aldehyde which have a CH3COO bond, it gives reaction with it gives iodoform reaction. Okay, and it is primary alcohol. So ethanol is the only primary alcohol which gives iodoform test. So this also gives iodoform test, and acetaldehyde also gives iodoform test. Next is ketone. So ketone also have this COOCH3 group here. It also gives iodoform test. So what is left with us? We are left with methanol. So methanol does not gives iodoform test. Okay, so this is the correct option, right? So yeah, this is the correct option. Methanol does not form iodoform test. Next question is question number 59. Yeah. The species having permanent dipole moment is. Which species have the permanent dipole moment? So here ClF3. This molecule has the permanent dipole moment. Why? Because it is non-symmetrical molecular structure. Okay, this is not symmetrical at all, and they are arranged in trigonal bipyramidal geometry around the central chlorine atom. So what happens that due to the electronegative difference between chlorine and fluorine, both are electronegative atom, but there is a difference. Fluorine is more negative than chlorine. Okay, and also there is a uneven distribution of electron density causing a net dipole moment. So a net dipole moment is generated in this type of molecule, which results in a permanent dipole moment for the molecule. Okay, so ClF3 is the compound that has the permanent dipole moment. Next is question number 60. For question number 60, sorry, the number of angular nodes and radial nodes in 3p orbital are. So in 3p orbital, we know that the number of angular nodes is L, oh sorry, it is 1. Yeah, it is 1. So we know that the number of, oh, it is L only. Yeah, it is L. So the number of angular nodes is L, and we know that the number of radial nodes is n minus L minus 1. Okay, n minus L minus 1. This is the formula. So the number of angular nodes and radial nodes in 3p orbitals are 1 and 1 respectively. Okay, both are 1. For 3p, n is equals to 3 and L is equals to 1. Okay. So here on putting, so number of angular nodes. What is the number of angular nodes here? Angular nodes comes out to be L, which is 1, and the radial nodes comes out to be n minus L minus 1. N is 3, L is 1, and 1 is there. So which means 2, right? Sorry, which means 1. 3 minus 2, right? 3 minus 2, which is 1. So both are 1. For angular node is also 1, and for radial node it is also 1. So which will be the correct answer? Option number 3 will be the correct answer. For question number 61, we have to determine the IUPAC nomenclature for this molecule. So see, there are two functional group present. Okay. So if two functional group present, here it is ketone and here it is carboxylic group. So we have to first find out that which has the higher priority. So we know that the carboxylic acid group has the highest priority among all functional groups. So from here we are going to count the parent carbon chain. Here it is 1. This carbon has 2, 3, 4, 5 and 6. So there are 6 carbon. Okay. Then we have to name the substituents. So the substituents are named according to their alphabetical order. Okay. So here it is iodo group present, bromo and chloro group. So first what we have to do, we have to use the one which has the lowest alphabetical value. Okay. So which means bromine. So 3 bromo, then after it is chloro, 4 chloro, then iodo, 2 iodo. Then for ketone we will use 5 oxo. Okay, and for 6 carbon it is hexanoic acid. Okay, so which answer is true? First one, first option is correct. Okay, so yeah, for next question, question number 61, right? This is question number 61. For question number 62, yeah, the shape of the following molecules are. What is the shape of these molecules? PS3 NH4 plus XeO2F2. Okay, so okay, let's draw this. For PS3, the shape of PS3 is like this. Okay, here it is H, here it is H, and one lone pair is present. This is the shape for PS3. The phosphorus, okay, let's draw all of these first. Okay, for NH4 we have 4 hydrogen atoms are attached to nitrogen and one positive sign is there. For XeO2 and F2, 2 F are there and one lone pair is also present here. Okay, so let's see its hybridization. So phosphorus has a hybridization of sp3 and it has a shape of pyramid. Okay, it has a pyramidal shape for PS3. For NH4, this nitrogen also has a sp3 hybridization, but its shape is tetrahedral. Okay, and this XeO2F2 has a sp3d hybridization and its geometry is seesaw. Okay, why it is seesaw? Due to the presence of lone pair. And here also sp3, it should be tetrahedral, but because of the presence of a lone pair it is pyramidal in nature. Okay, so option 2, pyramidal. PS3 is pyramidal, NH4 is tetrahedral and XeO2F2 is seesaw. Option number 2 is the correct answer. Let's move on to question number 63. when 50 ml of 0.1 molar NaOH is added to 50 ml of 0.1 molar acetic acid solution, the pH will be. What will be the pH for question number 63? Okay. So, it is a type of neutralization reaction, right? So 50 ml of NaOH plus acetic acid, what it will give? It will give sodium acetate and water. Sodium acetate is a salt. So initially NaOH has 50 ml volume and its molarity is 0.1 molar. Acetic acid has 50 ml volume and its molarity is 1 molar. So finally we will have NaOH as 0, CH3COOH as 0 and sodium acetate as 5 millimolar, right? So for molarity we are going to calculate, it is 5 by 100, which means 5 into 10 to the power minus 2. Now what we have to find? We have to find the pH. Okay, so for pH we can use this formula, pH equals to 7 plus half pKa plus log C. Okay, so pKa here is the value which is given 4.74. Okay, it is 74. And for log C comes out to be, log C is the concentration, which is mainly the molarity. It is 5 into 10 to the power minus 2. Okay, on solving this we will get 1.3. So the answer comes out to be, the pH is going to be 8.72, which is option number 2, right? Now for question number 64. For 64, if A naught be the radius of the first Bohr orbit of the hydrogen atom, the de Broglie wavelength of an electron revolving in the second Bohr orbit will be. Okay. Sorry. If the radius of the first Bohr orbit of the hydrogen atom is A naught, okay, so radius is A naught given here. So we know that we have to find out the radius for the second Bohr orbit, right? So for second Bohr orbit of hydrogen, what is the formula? It is A naught N2 by Z. N is for second Bohr orbit, it is 2 square and Z is 1 for hydrogen, right? So it comes out to be 4A naught. It comes out to be 4A naught. Okay. Now for second Bohr orbit, the formula is 2 pi r into n pi. So 2 pi, let it be as it is. For r we have calculated to be 4A naught. So r is 4A naught. For second Bohr orbit, n value will be 2 and it is lambda. So 2 will get cancelled out. So what will be the Bohr orbit value? So lambda will be 4A naught pi, right? This will be the correct option. Lambda equals to 4A naught pi. So which is the correct option? Question number 64, correct option is 4 pi A naught. Okay, option number 2. Clear? Next is question number 65. Which of the following is the weakest base among the following? Which is the weakest base? Okay, so these are the options. Question number 65, right? Yeah. We have to find that which of these is the weakest base. So let's write some points. So if an electron withdrawing group is there, what happens when an electron withdrawing group is there? It stabilizes the CH2 group. Okay, the carbanion group. It stabilizes the carbanion group. And which type of electron withdrawing group is present? In all the cases there is NO2, nitro group present. Okay, so this part is same for all, only the position of nitro group is changed in every option. So let's see, here nitro group is present, here nitro group and here. So what happens now? The correct option will be, according to me, option number 4. Why? because the nitro group which is attached to the CH, what it will do na, it will create a resonance type structure. So all of the molecule will resonate, it will form resonance, okay, and it will also stabilize the CH minus group, okay, by inductive effect. It also applies inductive effect and it also participates in resonance. So if all of this is going on in this case, then it will be a weakest Lewis acid. Okay, weakest base or weakest base. Yeah, it will be the weakest base. Option number 4 is the correct option. So for question number 66, question number 66, among the three orbital types, namely P, D and F, option 1 says both P and F orbitals have a center of symmetry, both P and D orbitals have a center of symmetry, only D orbitals have a center of symmetry, and only F orbitals have a center of symmetry. Okay, so let's roughly draw the sketch of SPD orbitals. So S orbital, we know that it is spherical shape. Okay, S orbital. P orbital, it is dumbbell shape. Okay, like this or like this. And D orbital, this is P orbital, and D orbital, it is double dumbbell, okay, or like this, okay. So it is talking about the center of symmetry. So S orbital has a center of symmetry, P orbital does not have any center of symmetry, okay, and D orbital also have a center of symmetry. So which means that the center of symmetry is shown in S orbital and D orbital, okay. So option number 3 only for 66, okay. No, I think option number S and only D orbital. Yeah, okay, sorry. Only D orbitals have a center of symmetry. S orbitals does not have a center of symmetry, okay. Only D orbitals have a center of symmetry because these are double dumbbell shaped. Yeah, only D orbitals have a center of symmetry. For question number 67, choose the correct option regarding the following assertion and reason. So assertion says that in order to keep a track of electron shifts in chemical reaction, involving the formation of covalent compounds, a more practical method of using oxidation number has been developed. Okay, it is saying that in order to track the uh, chemical reactions involving the formation of covalent compounds, oxidation number method has been developed, okay. So this part is true. Why? Because oxidation number allows us to depict the change in apparent charges of atoms, okay, without complete electron transfer, even when complete electron transfer does not occur, which is often in the case of covalent bonds. So what happens now in covalent bonds? The no complete transfer of electrons. In most of the cases, the complete transfer of electrons does not takes place. Okay, so how can we say that the reaction has occurred? By the change of oxidation number, right? If our oxidation number is changed, then we can say that the reaction has occurred. So this assertion is true. Let's read out the reason also. In this method, it is always assumed that there is complete transfer of electrons from a less electronegative to a more electronegative atom. So this method assumes a complete transfer of electron from a less electronegative to a more electronegative atom. So it is assumed, okay. So here both the assertion and reason are correct and the reason is the correct explanation. So option number 1 is the correct answer. Okay, the reason is also correct and the assertion is also correct. For question number 68, identify the D. What is D here? Okay. So here this is cyanobenzene, cyano group is attached, or we can say it is benzene nitrile also. Okay, cyanobenzene on hydrolysis H3O plus and heating, it will, the CN group will change to COOH group. Okay, then on addition of NH3 and heating, it is changed into amide CONH2 group. Then again when it is treated with LiAlH4, it is reduced and hydrolysis, and on hydrolysis it will give CH2NH2. Okay, CH2NH2, it is amine is formed. So the answer, correct answer will be CH2NH2 one, which is option number 4. Yeah, it is option number 4. In question number 69, what happens in question number 69? The mass of calcium deposited at the cathode by passing a current of 5 amperes for 9.65 hours to a molten solution of calcium chloride is. For question number 69, the current is given of 5 ampere, time is given to be 9.65 hours, and it is asking that how much mass of calcium will be deposited. Okay, so we know that the number of equivalent calcium deposited is equal to the number of Faraday of electricity passed. So what will be the number of Faraday? Okay, it will be charge into time, we have to convert it into seconds. Okay, this is the current and this is the value of Faraday. Okay, 96500. So mass of calcium deposited will be this is, it comes out to be 36 gram. Okay, it comes out to be 36 gram. Okay, there is a more better way that we can solve this. Let's find out some space. Question number 69, right? Yeah. So for question number 69, we know that current is equals to 5 ampere and time is equals to 9.65. It is in hours. We have to convert it into seconds. So 9.65 into 60 into 60, which comes out to be 34740 seconds. Okay. Now again we have to find out the value of charge. So charge is I into T. Current is given, I is current. So it is 5 into the time which we have converted into seconds, 34740. It comes out to be 173,700 coulomb. You can cross check also. Okay, the values you can cross check, or otherwise it is mostly correct. You can focus on the formulas which I am using. Okay, so now focus on this. 2 into 96500. Okay, 2 into 96500 coulomb is required to deposit, this much energy is required to deposit 63.5 gram of copper. Okay, it is the molecular weight of copper. It is the molecular. So 1 coulomb of energy will be required to deposit 63.5 divided by 2 into 96500. And how much we have to find out? We have to find out this much charge, 17370. This much charge is required to deposit how much coulomb of energy? 63.5 into 2 into 96500 into 17370. Okay, like this. So what will be the answer? The answer comes out to be question number 69, right? Answer comes out to be 36 gram. Answer comes out to be 36 gram. Okay, so you can solve further, the value you can calculate. For question number 70, what change in entropy can be observed when 1 mole of a perfect gas expands isothermally to 10 times its original volume? So its initial volume is 1 and its final volume is 10 times you have to calculate. Let it be 10. Okay. So for calculating the change in entropy, which means it is delta S. Entropy, the symbol of entropy is S, right? Change in entropy, automatically it becomes delta S. So delta S equals to 2.303 NR log of VF, V final by V initial. So N value is 1 and V final we have taken as 10 and V initial is 1. So delta S value comes out to be 2.303 into R. Okay, which means first option is the correct answer. For question number 71, for question number 71, with the increase in molecular weight, the boiling point of halogen increases. It happens because, so why it happens? As the molecular weight of halogens increases, the more electron per molecule are there. Okay, which results in strong van der Waals forces between the molecules. So as the molecular weight increases, the van der Waals forces also increases. Okay, which results in higher boiling point. So option number 1, van der Waals forces increases as the increase of electrons per mole. So this is the correct option. For question number 72, okay, what weight of copper will be deposited by passing 2 Faraday of electricity through a solution of copper 2 salt? 2 Faraday of electricity and weight of copper is asked in the question. So we can write it as this: 2 Faraday electricity. 2 Faraday's electricity implies that 2 moles of electrons are exchanged. Okay, 2 Faraday means 2 moles of electrons are exchanged. So we know that Cu plus 2 electrons will give Cu solid. So 1 mole of Cu is formed by 2 Faraday from, okay, 1 mole of Cu is formed from 2 moles of electron. Okay, so weight of copper is 1 into what is the molecular weight of copper? It's 63.5 gram. So weight of copper also turns out to be 63.5 gram, right? And for the detailed solution, you can refer it to this explanation part. Okay, it is very much lengthy. Yeah, see, Cu plus 2 Faraday, it gives Cu solid. So 1 mole of copper is deposited, which is 63.5 gram. Okay, 63.5 gram. Option number 2 is the correct option. Question number 73. Question number 73. Which statement best explains why the OCH3 group is ortho and para-directing in electrophilic aromatic substitution? Okay. So which of these explains that why OCH3 group is ortho and para-directing? So the OCH3 group is electron donating group, which increases the electron density around the, okay, so OCH3 group is the electron donating group. Okay, so what it does, it increases the electron density. It increases the electron density around the ortho and para position relative to the meta position. So which position is ortho, which is meta, and which is para? Let us assume that here it is OCH3 group. Okay, or consider there is another group. Let it be OH. It is OH. Okay, so this and this position with respect to OH, it is ortho. This and this position, it is meta, and this position is the para. So what happens now? The OCH3 group increases the electron density around the ortho and para position, and with relative to the meta position. So ortho and para position will experience greater electron density. what will happen then more nucleophilic and which will make them more nucleophilic, so they can attract the electrophilic attack. Okay, electrophilic attack can be done there more precisely, more quickly, you can say. So option number 3, it enhances the electron density at the ortho and para position, OCST group. Okay, question number 73 is the correct option. For question number 74, nitrogen does not form pentahalide due to, why nitrogen does not form pentahalide? Due to the non-availability of the d orbitals. Okay, it does not have d orbitals. It is not present in the d group. So it does not have any d orbitals. Question number 75. Okay. Determines Boyle's temperature if the critical temperature of a gas is 160 Kelvin. So for Boyle's temperature, we can say that Tc by Tb is equals to this. Okay, what is Tc? Tc is 8a by critical temperature. It is okay, 8a by 27 Rb. And what is Tb? It is 8 by Rb. A by Rb. On taking the ratio, it comes out to be 8 by 27. Tc value is given here as 160 Kelvin and we have to find Tb. So on solving, we will find Tb as 540 Kelvin. Okay. Uh, 1 second. Yeah, sorry for the voice. This is the type of weather, right? सभी को आजकल cold and cough हो रहा है. This is so normal in this weather. But you all please take care of yourself, as it is a crucial time for your preparation, right? Okay, so question number 76. Yeah, I have discussed now why 540 Kelvin is the answer. 540, which is option number 2. Question number 76. Upon nitration of acetanilide followed by hydrolysis, what is the expected product? What is the expected product here? Question number 76. Okay, I need to show you the reactions then. For question number 76, here we can solve. Upon nitration of acetanilide, this will be the structure of acetanilide, NHCOO, here it is CH3. Okay, this is acetanilide on reaction with conc HNO3 and conc H2SO4. What we will get? A nitro group is introduced at the ortho position. Okay, and another nitro group is attached at the para position. We can say that this is ortho-directing and this is para-directing. Ortho-acetanilide and para-acetanilide. Okay. On hydrolysis, it is said that on hydrolysis, what is produced? So on hydrolysis, what happens now? That this group is converted into an amine. Here it is NH2 and here it is NO2. Here it is NH2 and here it is NO2. This is ortho-nitroaniline and this is para-nitroaniline. So what will be the correct answer? Option number 3. Ortho and para-nitroaniline. Okay. For question number 77. The small increase in the covalent radii from Si to Pp is due to the presence of so there is a considerable increase in the covalent radius from carbon to silicon. Okay, thereafter from Si to Pb there is a small increase in the radius, which is due to the presence of completely filled d and f orbitals. Option number 2 will be correct. Okay. Okay, so let's move on to the next question. Question number 78. Consider the following cell reaction: Ni solid plus 2Ag plus at 0.022 molar. Molarity is given here. Gives Ni plus 2, 0.16 molar plus 2Ag solid. Okay. Consider the following cell reaction. This cell reaction is given. If E naught cell equals to 1.05 volt, then E cell will be. E naught cell is given to you. What will be the E cell? Easy, the E cell will be E naught cell minus 0.0591 by N log of Ni plus 2 concentration by log of Ag plus whole 2 concentration. Okay. E naught cell is given to you. It is 1.05 volt and N value is not given. Okay, N value we can calculate, right? N value we can calculate, and log of Ni plus 2 is written and log of Ag plus 2 is written. So on solving this equation, we will get 0.91 volt as the correct answer. Option number 4. Okay. For question number 79, which of the following statement is true for the given sequence? So here an anisole is given, and on reaction with Br2 in ethanoic acid, it will give A as the major product, and on reaction with HBr, it will give B plus C as the products. Okay. So A, what we have to find out that A, B and C. First we have to find out the products of A, B and C. So A here will be OCS3, and at para position here it is bromo. Okay, ortho one is also formed, but here it is written that which is the major product. Okay, so para bromo anisole. Para bromo anisole is the product A. B here will be phenol. Okay, B here will be phenol, and C will be CH3OH. So let's read the option. A and B are isomers. No, A and B are not isomers. C is methanol. It is correct. A is para-directing. A is para-bromoanisole and C is methyl bromide. Okay, sorry. Here it is methyl bromide. Methyl bromide is formed. Option number 3 is the correct answer. Okay. Yeah, for question number 80. For question number 80, the equilibrium constant Kp for the reaction is XA. Okay, we have to find out the equilibrium constant. Okay, Kp, we have to find what is Kp. The reaction is given to us when reactant X decomposes to 50% at 5 atm pressure. Okay, so this is the reaction given here. At total pressure, P at total pressure, X is 1, Y and Z are 0, and at equilibrium, X is 0.5 and Y is 0.5, Z is also 0.5. So on solving the value of Kp, which comes out to be P alpha square by 1 minus A, it comes out to be 1.67 atm. Okay. Option number 2, 1.67 atm is the correct answer. Question number 81. The ratio of time taken for the ratio of time taken for 99.9% and 99% completion of first order reaction is, okay, the ratio of time taken for 99.9% and 99% of completion of a first order reaction is, okay. So for T99 we know that 1 by k ln 100 by 100 minus 99 comes out to be this. For T99 it is 1 by k ln 100 by 100 minus 99, it comes out to be this. Then the ratio of T99 and T99.9 and T99 is 3 by 2, okay. So the ratio is 3 by 2. Next is question number 82. Choose the correct option regarding the following assertion and reason. Assertion and reason. What is the assertion here? Assertion is glycerol is purified by distillation under the reduced pressure. Okay. So explanation, glycerol can be separated from pent 1-ene in the soap industry by using this technique. It is so glycerol can be purified by distillation in the reduced pressure. Okay. So this is correct. For reason, method of distillation under reduced pressure is used to purify liquids having very high boiling points and those which decompose at or below their low boiling points. Okay. So the method of distillation under reduced pressure is used to purify liquids having very high boiling point. Okay, it is also correct. And for those, yeah. So assertion and reason both are correct. Option A is the correct answer. Question number 83. Which of the following oxidation state is shown by gallium, indium and thallium? So these all show +3 as well as +1 oxidation state. Okay. Sorry. For question number 84. Next is question number 84. If the half-life time of a first order reaction is 10 minutes, then the time required for 87.5% completion of the reaction is. What is the time required for 87.5% completion? Okay, so it will be 3 into half-life times. Okay, so it will be 3 into 10, which is 30 minutes. 30 minutes. This is the shortcut. Okay, this is the short form of solving the question. You can also use the main formula, which is for first order reaction T87.5 we have to calculate. It is 1 by k ln of 100 by 100 minus 87.5 equals to 1 by k ln 8. Okay, this one you can also use for calculating the answer. For question number 85, which of the following species will have the highest ionization enthalpy? So highest ionization enthalpy, we know that ionization enthalpy increases from left to right. Okay, so silicon, it is silicon. Silicon will have the highest ionization enthalpy. Option number 4 is the correct option. Question number 86. Indicate the Van 't Hoff factor for a weak 0.01 molar monobasic acid. pK of an acid is given as 4. Okay, so Ka is equals to concentration into alpha square, and alpha comes out to be root under concentration of Ka by C, which comes out to be 0.1. So we know that Van 't Hoff factor is 1 plus alpha. Okay, 1 plus alpha, which comes out to be 1.10. 1.10. Option number 4 is the correct option. Next is question number 87. The effective nuclear charge experienced by the valence electron in an atom will be less than the actual charge on the radius. So what will be this appropriate reason? The effective nuclear charge experienced by the valence electron in an atom will be less than the actual charge on the nucleus. Okay, why? Because of the shielding or screening effect of valence electrons. Because of the shielding and screening effect of the valence electrons, the effective nuclear charge is less than the charge of the nucleus. Okay. Next is question number 88. The product obtained when ethyl magnesium bromide, ethyl C2H5, ethyl magnesium bromide reacts with methanol. Okay, what is the product? So these both, when react with each other, ethane will be formed. Ethane is the product. Okay. Question number 89. This compound is colorless and diamagnetic, colorless and paramagnetic, colored and octahedral, or colored and paramagnetic. So for this compound, Sc is in +3 oxidation state. +3 oxidation state, which means 3d0, which means that it does not have any unpaired electrons. All the electrons are paired, and also 0 electrons are there in the d orbital, which means that it will be colorless, and also all are paired. Nothing is unpaired, which means it is diamagnetic. Its magnetic moment will be diamagnetic. Next is question number 90. The geometries of the complex formed by ammonia. We have to find out the geometry of all these complexes. Okay. So when ammonia is formed, ammonia forms the complex with all of these three. These are the complexes. For Ni1, it will be the geometry will be octahedral. For platinum, the geometry will be square planar, and for Zn, the geometry will be tetrahedral. Option number 1. Option number 1 will be the correct answer. Question number 90. Yeah, it is only repeated. It is repeated twice. For question number 91. For question number 91, arrange the following in the correct order of reactivity towards phenyl magnesium bromide. Okay, so for phenyl magnesium bromide, what happens? Okay, first one is PHCOPH. Okay, like this it is. This is the benzene ring, this is carbonyl group, and this is another benzene ring. Okay, this is PHCOPH. Next is CH3COOH, and next is CH3CO. It is acetone. Okay, so all the things, the correct order of reactivity depends on the, you can say, crowding. Okay, or the steric crowding. So in which of these the steric crowding is the most in this group, which means that it is the least reactive. So reactivity, this will be the least reactive. Let it be number 3. Okay, okay, this is the 1, this is 2, and this is 3, right? Okay, so the order of reactivity, 1 has the least reactivity, then option 3, and then option 2, which means 2 is the most reactive. So 2 is the most reactive in 3 and 4. Then after 3 is the most reactive. Then 1, which means that fourth one is the correct option. Okay. Question number 92. Yeah. What will be the ionization isomer of this compound? So ionization isomer means that the ligand which is present inside the coordination pair and which is present outside the coordination pair, na, they are interchanged. Okay. So if chlorine comes inside the coordination pair, then it will be Cl2, and nitro group will be outside the coordination pair. So here option number 2 will be the correct option. See, chlorine has 2 and nitro group is outside the coordination pair. Okay. Question number 93. The values of Henry's constant for argon, carbon dioxide, methane and formaldehyde are respectively, they are given. The correct order of their solubility. So the value of solubility, argon has the highest, then CO2, then CH4 and then HCHO. So their order of solubility will be like this. Argon has the least solubility. Okay, option number 3. Option number 3 will be correct. For question number 94, which option among the following demonstrate the highest level of basicity in nature? Okay, so basicity, as we move left to right to in lanthanoid series, as we move from left to right, the covalent character increases and the basicity decreases. So basicity decreases, which means that first one, lanthanoid, has the highest basicity. Okay, because these groups are formed as we go to right. Okay, and on moving to right, their basicity decreases. So the highest basicity will be the first lanthanoid one. Question number 95. The compound among the following which does not give Felling's test. Okay. So the Felling's test, aromatic aldehyde give Tollens test. Aromatic aldehydes does not give Felling's test. So which is aromatic among all these? Benzaldehyde is aromatic. Okay. So it does not give the Tollens test. Felling's test. It gives the Tollens test. Okay. Question number 96. Which of the following compound is not colored? Which is not colored? Second option. This is not colored. Why? Because they have D0, they have D0 or D10 electronic configuration. Okay, which means that it is either empty orbital, no electrons are there, or it is completely filled. Therefore it is not colored. Okay. Question number 97. Tertiary amine is obtained in the reaction. So among all these reaction, which will yield a tertiary amine? Tertiary amine, 3-degree amine. So answer is 1. Aniline. Aniline will react to give tertiary amine. So okay. So aniline and CH3I, they react to give this complex, and then this complex is reacted with excess. You can see there is excess of iodomethane. Okay. Therefore and amine is formed. This is 3-degree amine. So 3-degree amine is formed in this case, okay, in aniline plus CH3I. Question number 98 states that the orange-red vapors obtained when mixture of solid NaCl and solid K2Cr2O7 is heated with conc H2SO4 due to, okay, question number 98, right? So NaCl and H2SO4 and K2Cr2O7. So these three, when they are mixed, it is chromyl chloride is formed, which is responsible for orange red vapors. Okay, which is responsible for orange red vapors. So chromyl chloride, option number 2. This will be the correct option. Question number 99. What are the substances that cause temporary hardness in water? So temporary hardness in water is caused by Ca plus 2 and Mg plus 2 ions. Okay, so fourth one will give Ca plus 2 and Mg plus 2. So this is the this causes the temporary hardness in water. Okay. Question number 100. Which of the following is C2 epimer of D-glucose? C2 epimer, which means, okay, D-glucose. So say, see, you can see here D-glucose, this is the structure of D-glucose, and C2 epimer means 1 position, 2 position, second carbon position we will see. Okay, so here second carbon and here second carbon, so these both are interchanged. This is the D-mannose. So D-mannose has the structure in which the D-glucose structure is slightly different. Its C2 epimers are changed. Okay, so D-mannose will be the correct option. Okay, yeah, so this much for today. Just look at these questions properly and practice all of them. Okay, thank you. Bye bye.